When we launched AWS Parallel Computing Service, we released a bunch of getting started guides, tutorials, and recipes so that you could build the cluster you needed for your workloads. Now, we're keeping this blog post here up to date with all those resources, and there's a YouTube playlist on this channel, so we've got everything covered that you need to set up and tweak the components for your stuff. Now, we were going to leave the one-click cluster moment until we launched full CloudFormation support for PCS later this year, but watching customers watching us told us you wanted that sooner. So today, Matt Vaughan is going to walk you through a truly one-click shopping experience, HPC style. You can find this recipe, as always, in our HPC Recipes library here. It takes 15 minutes after you launch it, and at the end, you'll have a punchy 4-node little cluster that's using quite generic Intel-based Xeon instances with a home directory from Amazon EFS and a scratch file system using Lustre. It's what I call a pilot-like cluster because there's a login node that you can connect to right away, but the compute nodes themselves don't exist until you bring them into life by launching a job. That's kind of how clouds are meant to work. Now, the cluster we stand up is a pretty faithful copy of the one in the Getting Started guide in our online documentation. It comes with one Slurm partition, but if you wanted another one or another 6, knock yourself out. The virtue of having a look ma no hands cluster is that you can jump straight to the aha moment at the end right away, play with PCS and just get used to it. You can use this cluster as is. You can also fiddle with everything and turn it into your own cluster. You could add your own queues, define your own node groups, fiddle with GPU nodes, or endlessly tweak the machine image to contain your own packages of goodness just the way you want them. You can connect your shiny new cluster to other AWS services as well, and in the act, create whole automated monster workflow pipelines. The future is only as weird as your imagination, and I'm not going to speculate how weird that is. If you're a good engineer, there's a chance you're going to break something in the act of trying to figure out how it works. That's solid engineering practice, in my view. And since you're only ever 15 minutes and one click from recovering what you screwed up, go your hardest, little engineer. This is how we learn. Anyhow, Matt is going to show you how to kick this thing off, and in the few minutes it takes PCS to build your cluster and all of its bits, he's going to walk you through the recipe so that you can see how these bits come together from the inside. Now, we're pretty sure you want to steal this recipe when you're done and make it your own, so this part of the video is just good education. If you want to skip to the end, jump to the chapter in the video called "The Cluster is Out of the Oven." We called them recipes for a reason.
So this is available in the HPC Recipes Getting Started with PCS recipe. And basically it is a set of CloudFormation quick create links, one for each region where PCS is available. You can click on these and you can get a complete working cluster that's identical to the cluster that you would get if you followed the tutorial in basically one trip through the CloudFormation console. So let's go ahead and kick one of these off. And then while it's building, which will only take about 15 minutes, we can go and talk about how it works under the hood. So here we are. Let's launch in US West 2, Oregon. Okay, so here we are in the CloudFormation console. We give it a name, pick a SSH key name, leave the AMI ID blank, leave our client-side or IP address as it is. This will allow inbound SSH access. We don't have to touch this HPC Recipes configuration. This is just for developers of these recipes. Go opt into our special permissions for IAM, and we're off to the races. So again, this is in the Getting Started recipe under Assets. The name of the template is cluster.yaml. So structurally, this is pretty standard if you've seen other CloudFormation templates in HPC Recipes. We have a little metadata that basically orders and organizes the way that the parameters show. Then we have our parameters, key name, AMI ID, client IP, and a couple of things for configuring which iteration of HPC Recipes we're working from. But the important part is down here in our recipes. So this is creating a nested set of stacks. First thing that we're going to create is this is a custom resource. You won't need this once CloudFormation support is officially available in PCS. We're doing it now. This custom resource handles the lifecycle events for the main cluster primitives, cluster, compute node group, and queue. It's designed for demos. You shouldn't build anything sophisticated on top of it, but this is what we're using today. So now we have our networking. This again is another nested stack. This actually reuses another HPC recipe, the large scale networking or HPC networking recipe. Next, we have our storage, basically EFS and FSX for Lustre. Again, these are just importing other templates from other HPC recipes, one for EFS, one for FSX Lustre. Security group, this is reusing the security group template that we provide in the getting started recipe. You could also build the security group inline in the template, doesn't really matter. Okay, so now we get into the meat and potatoes of things. Here's the cluster. So right now its type is its custom resource. Later, when CloudFormation support becomes available, this will be something like AWS PCS Cluster. But the important thing here is that the rest of the properties, cluster name, size, scheduler, networking, etc., map directly to the PCS Cluster API. So editing this to make it work with CloudFormation natively later on when that becomes available in the service will be pretty trivial. So now here we set up our instance profile. Again, this is reusing the instance profile setup that ships with the getting started recipe, and the same for the launch template. Note though, in this launch template, we are pushing in parameters from several other stacks. We're pushing in parameters from the networking stack, the security group stack, the storage stacks. So basically we're composing all of this together into that launch template. This is an alternative to, if you remember when you had to create that launch template in the getting started guide, you have to remember and kind of write down or copy and paste or select all of these different values in order to create that launch template. This is sanding off a lot of the rough edges of that part of the tutorial. So now we have our login, or we have our node groups. Here's the login node group. Very similar situation. Right now the type is custom resource. It relies on that custom resource. But then all of the rest of these parameters, cluster identifier, instance profile, instance configs, etc., are all map one-to-one to the actual compute node group API in PCS. So we just have two of these. We have one for login nodes, one for compute nodes, and now we have the queue. Same story, custom resource, the rest of the properties map to the queue API in PCS. So all the dependencies and interrelationships are handled under the hood. That's one of the beauties of using CloudFormation. Then we have our outputs. The outputs are kind of clever. So obviously, one output that we emit is the cluster ID, but that's kind of boring. We also emit two URLs. One URL, the PCS console URL, is a link to the cluster after it's launched in the PCS console. The other, EC2 console URL, is a link to that will basically search the EC2 console for instances that have been spun up as part of the login node compute node group. And since we defined that to be a static node group with one instance in it, this will return the login node instance that we're supposed to use to access the cluster. Okay, so that's it in a nutshell. This is pretty simple. One thing that's really cool is when we actually support CloudFormation in PCS natively, it will be very trivial to edit this document and bring it into specification with official CloudFormation support. And don't worry, we'll actually show you how to do that when CloudFormation support comes out. Okay, so here we are. We're back in the CloudFormation console. Looks like status is create complete. That means our clusters should be up and ready to go. Here's where we began creating the stack, 1515. Let's go look at the event trail, find the most recent event. Looks like the stack finished creating 1531. So this took about 15 minutes, 30 seconds. Including provisioning a file system, standing up a cluster. That's pretty cool. Take that acquisition cycle, take that step-by-step iteration of the getting started tutorial. All right, so let's go look at the outputs. Here's our cluster ID. Here, as promised, are those two URLs. We have EC2 console URL and the PCS console URL. Let's click on the PCS console URL. You can see we're not doing anything magic here. We're just routing to the cluster ID. Here we are, though. Our cluster is named after the stack, get started CFN. We've got two compute node groups, login and compute one. This will look super familiar if you've read through the getting started tutorial. Here's our queue named demo. If we go and look at the details, it uses a C6i, et cetera, et cetera. This is as close as we can possibly get it, identical to the cluster that you will get if you follow the tutorial step by step. Okay, so let's go back to CloudFormation. Let's go back to the CloudFormation stack, and now let's click on the EC2 console URL. This is my favorite piece of magic. What we've done is we've just launched the EC2 console URL, but then we've searched for instances with the tag mapping to the node group ID for the login nodes. So here's that single instance. We can click on it, inspect it, but since this instance is configured for access through SSM, we can connect to it. And let's just prove. So here's our home file system, 8 exabytes because it's EFS. Here's our shared file system, FSX for Luster. And let's run a couple of Slurm administrative commands. Let's run sinfo. There we go. There's our demo queue. There are 4 compute nodes in the demo partition, and that's basically the end.
Now, there are tutorials for all these topics. They're practically growing themselves inside YouTube as we speak. When you're done though, don't feel bad about dropping the whole stack and making it all go away. What's next? Go and play with this thing. Launch a job or two. Check out how things behave. Jump into the PCS console and mess with the definitions of the queue. Maybe create a new queue. If you're a good engineer, there's a chance you're going to break something in the act of trying to figure out how it works. That's solid engineering practice, in my view. And since you're only ever 15 minutes and 1 click from recovering what you screwed up, go your hardest, little engineer. This is how we learn.